that's it. Apart from the jokes, hello and welcome everyone to the online presentation. The topic is already declared by Mr. Vinod Shah. The topic will be like how to make your electrical panels safer by implementing the systems and the monitoring technologies which are currently available in the world. So let us start with an interesting conversation. This is a conversation not between Varun and Alia. Actually, it is a conversation between FIPRES and switchgear. Okay. So FIPRES is a product. Okay, so just consider it as a product. Switchgear is any kind of panel or something. Okay. So FIPRES says, "Hello, may I come in?" So switchgear says, "Hey, there is no space, buddy. I don't have funds to support you. Why should I take you in?" Right? So anybody, if somebody wants to enter your house, you will say, "Come on, buddy, I don't have money to feed you. Why should I take you in?" Right? So FIPRES says, "Yeah, we can be friends. I don't take much space and I'm very useful. I monitor contact connections and send alarm signal when they are overheated. No one in the world does it as efficiently as I do. I will help you avoid fire, arc flash and associated damage and be more reliable and safer in general." Switchgear says, "Oh man, I was looking for someone like you. All these years, my connections get overheated very often and it's very dangerous. But the maintenance team doesn't know about it. Are you able to warn them in time?" FIPRES says, "Of course. I will look after you 24/7 and as soon as I detect overheating, I will send an alarm to SCADA system for the maintenance team so that they can check and do the corrective actions as soon as possible." Switchgear says, "Awesome. Exactly what I need. Please come in." So in this way, this is a love story between a FIPRES and switchgear. We hope, we should all pray that this love story should become real and FIPRES should be implemented in every switchgear, whatever is present all around, to make it safer. Okay, let us proceed. I'm Mubarak Khan, as introduced by Ninad sir. That was a really nice introduction. Thank you very much, Ninad sir. So I'm from Streamer Electric AG. They are basically founded in 1996, having cooperation with 5 universities and having various R&D offices, various offices across the world. We have a number of employees of different nationalities in different countries and having customers and presence all over the world. Okay, headquarters is in Switzerland. So let us start without all the company introduction, everything. We'll directly start with the technical topic because that is what you are interested in, right? So let us start. So what is a loose connection and what are its effects? Okay, we start with this. So what is a loose connection? Basically, there are a lot of hazards of electricity. Around 25% of building fires are due to electrical malfunctions. 32% fires in Germany are related with electricity. $3.2 billion of annual damage in US and Europe alone are occurring because of electrical fires. Now, oh, come on, it is a European figures. I'm not worried about it. Right? Okay, let us talk about the Indian figures. Indian figures says that 56% of all the industrial disasters in India are due to electrical faults. Okay, so in India or the world, the system is same. So definitely it is applicable everywhere. Okay, let us proceed. So this is a hazard overall, just a brief overview. Let us see what is a loose connection. Okay, loose connection means your connections are not tight, right? What are the main reasons of electrical fire? It can be loose connection, it can be overload, it can be improperly selected equipment. Like if you select a higher load for a lower feeder, something like this, or aging, arc faults, conductor insulation failure, etc., etc., etc. Now the thing is that in case of overloads or aging or improperly selected equipments, you know what? When the system faults start, like if your load is drawing large amount of current, what happens is your system is bound to overheat, and which point will heat more? That is the point where the connections are loose. They are not tightened properly, or your conductor is not of a same thickness. Like somewhere the conductor is little bit thin. So if the conductor is thin, the heating will be more at that point. If the conductor is tampered by heating or something, there will be heating at that point. Or if there is a connection and the joint is not perfect, improperly made, then there will be a heating at that particular joint. Okay. So if we talk about various different faults, mostly the fault occurs at the point of loose connection. So that is why we need to focus on the loose connection so that we can avoid majority of the issues. Okay. I hope you understood. If not, anyway, through the presentation, it will be covered in more detail, so it will be more easier for you to grasp. If anytime you think I am very fast or my accent is not audible or clear to you, you can just interrupt and tell me, okay? I'll just try to speak in some other accent, maybe African or Southeast Asian, okay? No issues. So, loose connections. There can be various causes of loose connection. It can be because of poor mechanical connection or oxidation at the connections. Okay, poor mechanical connection means a poor electrical connection may show up when the connections are not tight or dirt or other contaminations come between the contact surfaces. Okay, so connections are not tight. Actually, everybody knows. Okay, connections are not tight. It is loose. That's it. Now there can be a loose connection problem because of oxidation at the connections also. What do you mean by oxidation at the connection? Normally we have copper, which is used as a conductor, right? Copper is having an excellent conductance, right? It is having very low resistance over the length, so it is having very good conductance. But you know, copper oxide is not such a good conductor, or cuprous oxide is not such a good conductor. Okay, this is 1 o'clock. Reminder for me. Sorry. Okay. Just I'll wait for 2 seconds. Okay, so oxidation at the connections, right? So copper is very good conductor. Copper oxide or cuprous oxide are not so good conductors. Now, when copper is exposed to atmosphere or the chemical environment, like in the influence of oxygen and nitrogen, ozone, or some other chemicals which are reacting with the copper and causing the formation of cuprous oxide. They are causing the formation of the cuprous oxide. Okay, and this cuprous oxide, because it is not a good conductor. Now, if this cuprous oxide is coming between the contact surfaces, the contact resistance will definitely increase. So that is why oxidation increases the resistance, hence increases the overheating. So there are two causes. One is loose connection. Second is the reaction. Okay, the chemical reaction, the cuprous oxide. Now there is some relation between these two that we will see in further slides. Okay, in next slide. Anyway, we'll take an example before that just to see first part of loose connection. How loose connection causes overheating. Okay. So here in this slides, the two examples are given of a very small, simple power supplying to a heating element, 12 ohm heating element. Okay, so it is a 240 volt power supply supplying to a 12 ohm heating element through a circuit breaker, a terminal block, and a heater. Okay. Under normal conditions, 240 volts power supply will be supplying directly to the heating element. The resistance of the heating element is 12 ohm. So the power dissipated in the heater will be 4,800 watts. Okay, no issues. Everything is okay. The power dissipated in the heater, in the terminal block will be 0 because there is no resistance there. The power dissipated in the circuit breaker also will be equal to 0 because there is no resistance there. Okay. Now, what if there is a loose connection at the terminal block. Okay, so here in this example we have taken a loose connection at the terminal block to be around 12 ohm caused by poor connection. Okay, 12 ohm of loose connection caused by poor connection at the terminal block. Now in this case what will happen? 240 volt power supply will try to supply to the heating element, but because there is a resistance in between, the voltage will be distributed between the terminal block and the heating element proportionally, depending on the resistance according to the Kirchhoff voltage law. I hope you remember Kirchhoff voltage law. If not, it is very simple. The summation of all the voltages in a loop is equal to 0. So 240 volt supplying has to be equal, proportionally distributed between the two, that the supplying and minus the power voltage drop should be equal to 0. Okay. So here in this case we have taken the resistance of the loose connection as 12 ohm just for simplicity. So 12 ohm loose connection at the terminal block, 12 ohm heating element. So the voltage will be equally distributed between the two. Okay, so there will be 120 volt power drop, voltage drop at the terminal block, and 120 volt voltage drop at the heating element, right? So power dissipated will also be equal on both. So if you calculate it, around 1200 watts of power will be dissipated on the terminal block and the same amount of power will be dissipated on the heater. What is its effect? इसको करने से क्या होगा? What is the problem? Now the issue is, when the power is dissipated on the heating element 1200 watt, nothing will happen to the heating element because it is designed to withstand large amount of energy. So nothing will happen to the heating element, right? Or the only thing will that the heating effect which it is creating, it will be reduced. It will not be enough. Okay, it will not be as much is required. Like it is only 1200 watts, not 4800 watts, what it was in normal conditions. But your heater will not burn. Now, what will happen if the 1200 watts, same amount of energy is dissipated on the terminal block? What will happen is, this 1200 watt energy will be dissipated on the terminal block. It is not designed to withstand that much amount of energy. The terminals are very weak, very small, so it cannot withstand that much amount of energy. So it will start to heat. The energy will start to get dissipated in the form of heat. Now your copper is very small amount of copper is there, so it will not be able to withstand that much amount of heat, and eventually either that immense heat will cause a fire if there is fuel in the close vicinity, or it will burn, right? If the contact will burn. Now we take two examples. One is very small wire feeding a small load, no problem. Consider a heavy current carrying bus bar supplying to a load, very heavy current carrying load. In this case, if the bus bar melts, there will be a huge arc flash which can damage anything and everything what is coming in the close vicinity, right? So under small current carrying applications, it may not be so much dangerous. It is still dangerous because if there is fuel in the vicinity, it can catch fire. And you know, normally this control cables, the PVC, the insulation of the control cables, they catch fire in majority of the cases. Okay. So if it is there, then it can catch fire. Otherwise, if the bus bar melts, then definitely it will be a huge disaster. Okay. So a natural indicator of a faulty wiring is its heat, because anyway, heat will be dissipated in that joint. I hope you understood this example. Now let us see what is a thermal runaway fire hazard of electrical panels. We'll see that. Loose connections. Loose connection can be because of overheating, right? And sorry, I'm really sorry. What is the sequence of events which is occurring between the bus bar melting and the fire, right? So when the connections are loose, current is trying to pass through that. It is not able to pass. So what will happen is the joint will start to melt. We'll take an example of a bus bar which is carrying around 2000 amperes of current feeding to a very large load. Okay. So when the connections are not tightened properly, because of that, the joint will start to overheat. Because of overheating, this bus bar is it is a copper made, the bus bar is made up of copper, right? So in presence of heat acts as a catalyst in the chemical reaction of copper with the atmosphere and the other things available, which I showed in 2 slides back, like ozone, nitrogen, etc. Right? So the heat becomes as a catalyst. Under presence of heat, the copper oxide is formed at a faster rate. Okay, and as you know, the resistance of copper oxide is higher than copper itself. So that is why, because of this oxidation, copper oxide will be formed. And because copper oxide is formed, the resistance will increase again further. Because of increase in resistance, there will be more heat. Because of more heat, again more oxidation will occur. More oxidation will cause more increase in resistance, and it will become a closed loop where heat will keep on increasing because of oxidation, and oxidation will cause the heating to increase. Okay. Eventually, in some time, this bus bar will reach to at a certain temperature where it will melt. Okay. Now you know, when two conductors are joined together, okay, when they break and heavy current is being passed through that, when you break it, there is an arc which is being produced there, right? And we have an arc quenching medium normally in the circuit breaker to use it. Now in this bus bar condition, this bus bar is here, it is carrying 2000 ampere of current, and the bus bar is melting. What will happen? This 2000 ampere will try to continue to flow, and after the bus bar has gone, it will turn into an arc flash. That arc flash will damage anything and everything which is coming in the environment. Okay. So this is the hazard which is being carried because of loose connection in the heavy current carrying applications. I will just try to explain the same thing in a more broader perspective, okay, with the help of a flow chart. Okay. So there can be three causes on the first top of this one. Electrical connections not tightened properly, dust, dirt or contaminations are coming between the contact surfaces, or there is a oxidation at the connection. Because of all these causes, there will be a effect known as the loose connection. Okay. Now, loose connections can be of two types. It can be connections are very loose, okay, or connections are insufficiently tightened. If the connections are very loose, it will directly go to the third stage. Okay. If the connections are insufficiently tightened and some overload occurs on that load, then this will again go to the third stage. Okay. So if the connections are very loose or insufficiently tightened, in both cases, it will go to the third stage. Now the thing is that sometimes people are saying the system is running from so long and it is not heating, so it is okay, it is good, right? It may not be, because maybe under the normal conditions all the joints are behaving normally, but as the current increases, the voltage drop at that particular point will increase and the resistance and the heating will increase. So definitely insufficiently tightening joints are also very dangerous. Okay, maybe after 2 months, 3 months, 6 months, 1 year, sometime your load will increase and your joint will give a flashover. Okay. So under both scenarios, there will be overheating of electrical joints. There will be oxidation at the connections, which will cause increase in resistance, and this loop will continue as I explained in the previous slide. So it will eventually cause increase in resistance, loop will continue. It can cause two things. Okay. First, excessive heat sufficient enough to catch fire if fuel is present in the close vicinity. Okay. Fuels like cable insulation or hydrocarbon fumes coming in contact with the heated surface can cause fire. Okay. There can be another effect where the overheating of heavy current carrying bus bar happens. Excessive temperature will cause melting of the bus bar. A large amount of current will be interrupted. The braking current causes a heavy arc flash, which will cause fire and disaster. So what is the solution? The flow chart is same. Initially, all the stages are occurring. Anybody saying something? Okay. So initially, all the stages are occurring. Anyway, you have any questions, you can ask in the question answer session also. Or if you want to interrupt, you can if you have any genuine question. No issues. Okay. So so all the initial stages are same. Then after the overheating is occurring, okay, at that time we have a monitoring system which can be installed and it can monitor the joints effectively 24/7 for overheating. So if there is a heating, it will give an alert to the maintenance team. Maintenance team can do the repair and there will be no fire hazard and the system becomes safe and reliable. Okay. As of now, people are not using any such solution. Okay. So that is why loose connections are actually causing the issues. As of now, people are not solving that problem. So we need to address and use various things. Now, what are the various technologies which are being used to solve this issue? The most common thing which people are using is thermography, right? We are taking thermography periodically so that we can monitor which joint is loose or some joint is heated, so we go and tighten it, right? Anyway, we'll discuss thermography also, but let us proceed from this part. Okay, so standard scenario of fire. What is a standard scenario of fire? Under normal conditions, okay, suppose this is taken an example of a one particular joint, one joint, okay, it is improperly tightened. It is not very loose. It is improperly tightened. So somebody sees and tries to shake it, it will be okay. It will be normal. It will not cause any effect. Okay? Now, what will happen is under the conditions of overload, initially the temperature of the joint will be around room temperature, around 25 degrees Celsius. When the overload comes, the temperature of the joint will increase. It will not become very high, but it will increase up to maybe 80, 90 degrees something. Okay, when the fault clears, the joint temperature will come down. Again, after some period, maybe month, week, or whatever, when the load increases again, the temperature of the joint will increase again. This time to a higher value. Okay, and then after the load is cleared, it will come down again. So it will keep on repeating multiple times throughout the life cycle of the equipment, coming to a point eventually when the contacts of the and the insulation are degraded. Okay, at this point, a point will come when your contacts are degraded, and in case of overload, the joint temperature will start to increase. Okay, it will cross 80, 100, 130. It will go to a point where your polymeric cable insulation will start to melt. Okay, then there will be smoke. If the temperature increases further, the PVC insulation will burn. It will cause smoke. It will cause ignition. Fire will occur, and sustained combustion will be there. Under these scenarios, your existing fire detection systems will work. You have a smoke sensor, fire sensor, or even the fire suppression system, which are being installed in some of the panels. They will only work after the fire has already occurred and damaged some of the equipment, right? So this is a standard fire scenario, how it happens. We will revisit this slide further in future, but just to understand how the fire occurs, we have seen this particular thing. Okay, now our focus is through thermography or other techniques. Our focus is to monitor and mitigate the issues within this range, within the safe zone of 80, 100 and 130, so that we eliminate the effects of fire, to. Okay. Now let us see how to avoid thermal runaway fire hazards in electrical panel. Okay. There are various methods to avoid the damages caused. Okay. There is remote monitoring of electrical joints. It is being done by continuous temperature monitoring through various techniques, or overheating monitoring through various techniques, or monitoring through visual fire prevention thermal level. Some people have promoted that you can install temperature stickers on the joints, and if the joint gets heated, the color of the sticker will change. Okay, so if you open and see it, you will know that during the operation this was heated. So you can take a corrective action. So this is known as the visual fire prevention thermal levels. Okay. Then there is one more method known as the thermal imaging, periodic thermal scanning of joints, where you take images of these joints over a period of time, like every 3 months, 6 months, or maybe monthly. Some people are doing. You take picture of the joint, and if some joint is getting overheated, you take a corrective action on that. Then there is an arc flash detection system, right? So if there is an arc flash, when the arc flash occurs, it tries to switch off the panel as fast as possible. People are also using fire suppression system, that if there is a fire in the panel, then it will extinguish it in the shortest possible time. Then we have a fire alarm system. Definitely, if the smoke comes out of the panel, then the fire alarm system will act and it will. So these are the various methods. We will try to see what is the comparison between them. Okay. Now let us start with the remote monitoring of electrical joints. Okay, how the remote monitoring of electrical joint works. So the system which I am proposing is FIPRES, a fire and overheating prevention system for electrical panels. There is various other methods also, which I will visit shortly. Okay, so remote fire prevention thermolabel, RFPT. It consists of three main components. RFPT, FPA and FPC. Okay, we will see individual one by one. The function is simple. These RFPTs are wrapped around the contact connections, joints, or the bus bars. Okay, when the joint gets overheated, a signal gas is released from the sticker. It fills the compartment with a particular gas concentration. That gas is being sensed by a sensor known as FPA, and this FPA gives a remote alarm. There is a question, fasteners are designed. Should I go to the question, or can somebody read out the question for me?
Yeah, I can read out for you. Do you want to take them right away or at the end?
Just tell me, sir, what is the question?
Yeah, so there is a question from Deepak Pandey. Hello, sir. What can be the reason about the burning leads in motor TB? That is one.
Leads in motor TB.
Yeah.
Okay, sir, there are various reasons. The leads can be burned. See, primarily it can there are things like, I'll simply tell you, loose connection. Okay, now under the presence of loose connection, it will not burn directly, but loose connection causes single phasing in the motor, right? And during the single phasing time, if it is not tripping in time, then it will cause a burning of leads. Okay. Now, this is one cause. In case of overload, if there is no single phasing, but overload is there and loose connection is there, right? In presence of overloads, the loose connection joint which is loose, it will cause immense overheating and it will burn. Okay. So under various scenarios, loose connections are the points which burn very fast. There can be other reasons, but these are the reasons known to me. Okay. Thank you, sir.
Yeah, and there is second question. Digvijay Kumar. So he's saying, Mr. Mubarak, fasteners are designed for defined tightening torques as per size. If one has tightened this fastener as per design, why same will start losing?
Why same will start losing?
I mean loosening, yeah, I think probably.
Okay, okay. See, if you tighten it properly according to the tighten torque with the manufacturer recommendation using the spring spanners or whatever. So if it is in that way, it is okay. Nothing will happen to the system. But the pity is people don't do it. Okay. Secondly, there are various factors like vibration, etc., which are there on the site, which causes even the joints which are tightened in the proper tightening torque to get loose. Okay. Third reason, during the operation and maintenance, when the operators they open the joint and close it, they don't tighten it with the tightening torque. We are all electrical engineers. Just let me know how many electrical engineers have torque spanners with them. Normally they tighten, right?
Yeah.
Even maybe in the factory they will use the torque spanner, etc. But in the site, you think they are using tightening torque spanner to tighten it? Very rare, very difficult, right? So if the maintenance, if the things are implemented in the best manner, definitely the faults will come very late, or maybe it will not come. But the pity is we don't do it in the perfect way. So to monitor the imperfect systems, we are showing the various things. Okay, that is one more thing. There is one more a chemical, a compound is there. If you put it between the joints and tighten it, then the remaining gap is being filled. It is a conductive paste. Okay, use it. If you don't use it, then you have a problem of loose connection. If you have all the procedures fulfilled, why will you have the problems, right? And these are the various things which we are recommending to use it, and this is one of them. Okay, so let us proceed anyway. Okay, so thank you, sir. You have any questions, you can write again, I'll reply. Okay, so this is the sticker. It senses the fire. It releases a signal gas. The signal gas is sensed by a FPA. FPA gives a remote alarm. Okay. Now we will see one by one. RFPD, remote fire prevention thermal labels. RFPDs are installed at contact connection points on electrical wires or some parts of electrical equipment which are potentially prone to overheating. When heated to activation temperature, a signal gas is emitted from the RFPD and is detected by the fire prevention alarm. Okay. So as I explained, the sticker contains there are two portions of the thermolabel sticker. First portion is the white portion which contains various indications. Okay. And there is a yellow portion which contains the signal gas embedded inside in the form of microcapsules. The outer layer of the microcapsules is calibrated as per the activation temperature. Okay. Now I'll just don't go for the too much technical terms. I'll just explain in brief. When the temperature, when this sticker is wrapped around the bus bar or the cable, sticker is wrapped around the bus bar or the cable, and when the temperature of the bus bar it reaches 50 degrees Celsius, it will the 50-degree dot will turn to black. When the temperature of the sticker will or the joint will increase to 70 degrees Celsius, the 70-degree dot will turn its color to black. When the temperature of the joint will go to 90 degree, the 90-degree dot will change its color to black. When the temperature reaches 100 degrees Celsius, at that time the signal gas will be emitted from the sticker and it will be sensed by a gas sensor which is installed in the same cabinet. So these are the various indications. 50, 70, 90 pre-alarm without any remote indication, only visual and local, irreversible change, and at 100 degrees Celsius signal gas will be emitted and it will give you a remote alarm. Okay, so that is the function. Now these stickers can be wrapped around the bus bars. On a bus bar, it will be wrapped like this. Okay, on a cable, small control cables, it can be wrapped like this. And on a circuit breaker, joint, jaw connection, etc., it can be wrapped like this. Why it is wrapped always? Just to maintain the adhesiveness. On the bus bar, normally we have some greasy component or dust, etc. So if you paste it on the bus bar, maybe the adhesiveness of the sticker will get damaged. So if you wrap it, then you become more sure that it will not fall down. Okay? Otherwise, it can work if you just paste it directly, or you can wrap it, no issues. Okay? Now these RFPDs are available in various temperatures and various sizes. Okay, temperatures depending on your application, and size depend on the size of the cabinet, because it has to release that much amount of gas which can fill that compartment. So depending on the size of the compartment, we have different size of stickers, and then depending on the conductor diameter. Okay, depending on the conductor diameter, they have different stickers. So for smaller conductor, we have smaller stickers. For bigger conductors, they have bigger stickers. Okay. Now coming to the second product, FPA. FPA product is very simple. It senses the gas. It gives you a remote alert. It gives you a remote alert. So like it can be given, your alert can be given through dry contacts or RS485 communication, or on a LED indicator also it is being shown. Okay. So there are these FPAs are also available in various sizes. For smaller cabinet, we have small FPA. For larger cabinets, we have very large FPAs. Okay. Now FPA fire prevention. This is a FPA with 4 coded sensors. So for very large compartments, more than up to 3 meter cube, we can use a multi-channel FPA where the sensors will be placed at different locations and the connections will be made to FPA, or a multi places with multiple cabinets. We will have one FPA with multiple sensors in each cabinet. It can be used in both ways. Okay. Now coming to the third product, FPC. It is very simple. It is a display and communication device. So whatever information is coming from FPA in RS485 communication, it will be displayed on the communication device. Okay. And then it will communicate this data to a remote PC through Modbus TCP/IP IC61850, or it can even send an SMS to the duty staff. So all the IoT functionality is available in the FPC220S. Okay. So that was a brief about the remote fire prevention thermal label system. This is the overall view. So I've already explained everything. No need to repeat. If you have not understood anything and you want me to repeat, I will do it now or later as you suggest. Okay. Now, okay. Now coming to the second part, is if bus bar is of aluminum type. What is the question, sir? Ninad sir, can you read out?
Yeah. Let me, so Swapnil Sonovan, if bus bar is of aluminum type, then whether the oxidation will occur, what is the impact with respect to copper bus bar?
Okay, so I'm actually, I have not studied the resistance behavior of the aluminum oxide, but definitely it is more than the aluminum. Okay?
Yeah.
Aluminum reacts in different circumstances than the copper. Actually copper oxide, its color is black, okay, and its resistance is very high. It occurs in the form when the heating is there, and the aluminum reaction is because of the chemicals. Okay, but I have not studied it in much detail, so I'm not able to comment. The aluminum oxide resistance is more than aluminum itself. Okay, yes, when I was doing the operation and maintenance, I had to go open the aluminum joints, clean them, put it back, and system used to become normal. Phenomena of oxidation. Sir, if I directly go into the oxidation process, this will divert us from the topic which we are trying to cover today. So let me finish this one, and then we can, in the end, if time permits, we'll cover that as much as I know. So this point we have covered remote fire prevention thermolabels. Now we will go to the second part, which is the visual fire prevention thermolabels. Okay. So remote is done. Visual means, as I explained, a thermolabel sticker is wrapped around the joint. Okay. And when the temperature of the joint increases, it will change its color irreversibly to black. When somebody opens the panel, when somebody opens the panel, then he will be able to witness that, okay, this joint was heated sometime in the past. Throughout the history, it was heated sometimes. I don't know when, but it got heated. Okay, this is one way. So one was remote, that as soon as you get the alarm, you get heating, you get a remote alarm. Second is, as soon as the heating occurs, the color will change to black, but you will only come to know when you open and see the panel. Okay. Now, benefits of remote monitoring or through the visual or remote. Okay, benefits of these two. This graph we have already seen, right? This remote fire prevention thermolabels or the visual fire prevention thermolabels, they detect the overheating of the joints in this zone, in between in the range of 80 to 130 degrees Celsius. That is why if you detect it in this zone, you will be able to avoid any hazards occurring in this zone. You'll be able to avoid any fire scenario to come. Okay, which will make your system which will make your system safer. Okay, so this is the achievement we get by remote monitoring at a particular temperature. Okay. Just a moment. Okay. Oh, okay. Now standard scenario using FIPRES. When you use a remote monitoring or visual monitoring, you get the alert before the temperature increases to a considerably high limit. So you do the repairs and system becomes normal. It will remain normal, because once you do the maintenance and tighten it properly, definitely it will not get loosened unless some external forces are causing it. So system will become normal. Okay. So this is the achievement which we get when we install the remote or visual fire prevention thermometers. Now let us compare with more methods which are available. Okay, first with thermography. Thermography is the most common method of monitoring overheating of the electrical joints, right? Now, but the issue is the thermography works only at the time of inspection. Like when I am doing the thermography, at that moment, if the temperature of the joint is high, it will be detected, otherwise it will not be detected. And we saw from so much discussion that the temperature of the joint can become high any point throughout the history because of what you call overloads, etc. Right? So it works only at the time of inspection. FIPRES works round the clock. Thermal imaging doesn't allow to check the equipment in locked enclosures, explosion proof, or the high voltage panels. With FIPRES remote or visual, you will be able to monitor the locked explosion proof enclosures also. For doing the thermography and the fault to be detected in the thermography, your load should be at least 60%. Otherwise, it will not be possible to do it. Right? FIPRES, it works 24/7. It works all the spots at the same time, and that is why in all the load scenarios it is working. So it will be able to detect it. Thermography it depends on the human factor largely, because somebody is doing it and his expertise is also required. But in FIPRES, no expertise is required. You just install it and forget it. If you have an issue, you will get an alarm. Right? Now there are more methods like arc flash detection systems or the fire alarm systems. As I explained, fire alarm systems work only after the fire has already occurred. Right? So if the fire has already occurred and you are getting an alarm, so definitely your damage is already done. Right? So it is not so effective. Now, moreover, arc flash detection systems are of two types. One is the AFDD, which is detecting small corona type of arcs which is coming inside the panel. Now, if these arcs are coming inside the panel, what will happen is the waveform of the voltage, it changes, and these devices, they detect that waveform change. It is only suitable for very small type of loads, for 220 volt household applications, not suitable for industrial. And secondly, it is only detecting the arcs. There can be so many faults in which arc is not produced at all, so you will not be able to detect it. Right? There is one more technology which is using arc flash detection or interruption system, in which they are using optical sensors to detect the arc. In that also, as I explained, arc may not be there always, but heat will always be there. So detecting arc may help sometimes, but heating detect will help in most of the times. Okay. Moreover, these two devices, they don't compete with each other, they complement with each other. You should have a arc flash detection system also, because it is a different kind of detection for different scenario. It also prevents fire. FIPRES may detect the arc flashes, but not always. Okay, so these are two complementing products. Okay, that was a comparison brief. If you want more details, we can have a discussion during the question answer or later. I'll give you my number. You can call me anytime. Okay, scope of application of the remote. So remote monitoring normally is required when your panels, you cannot open the panel, or your systems are really expensive. Then you will need the remote monitoring. Otherwise, in most of the cases, thermography will do, or you can simply avoid because the system is very small, right? So if the system is very expensive, then you can use, if your backup power supply is like the load to which it is supplying, if the load continuity of the power supply to the load is very important, then you must use a system like this. Okay, or if your equipment itself is very expensive, any damage can cause very heavy financial disaster, because anyway, if you install continuous monitoring, you'll have to spend money, so you need to see it if it is value for money only, right? Now, just taking an example for a high voltage panel, 11 kV switchgear, there are various compartments in that panel. So what we will do is we will install the RFID stickers at various joints. We will install the sensors in each compartment, and it will be connected to a multi-channel device, FPA here, and which can give a remote alarm. Okay, it will be installed like this, just to give an example of how it looks like inside a panel. Okay, this is a MCC PCC type of panel where we have multiple compartments. We can install stickers at all the joints. All these yellow marks are the stickers in the diagram, and all these things are the stickers in the images. Okay, then we can have a multi-channel FPA, which is installed here. You can see this. These FPA sensors are installed in different places. Okay, this is a small panel for small DBs in the hospitals or homes, etc. We can use this FPA with a single channel FPA with some stickers. Okay, conclusion. Definitely, remote monitoring works better than any existing fire system. It detects points of overheating before any dangerous situation comes. It monitors the equipment 24/7, allows to inspect the network equipment or quality of repair. Convenience, very easy to install. It can be connected to SCADA, real-time notification via SMS, and has dry contact output. And as expected by all of you, Streamer is manufacturer of FIPRES. So if you have any questions on that, you can ask us. Okay. There are more products of FIPRES which I'm not going to discuss now. Thank you very much. Okay. Thank you for your time and patience for listening to me. If you have any questions, you can ask. If